Today we are going to be talking our second day about graphing simple rational functions. Okay, and again, that word simple, it's not really like a specific like vocabulary word here. It's just basically simple because these are all going to be transformations of 1 over x, which its graph, if you remember from yesterday, we had vertical asymptote at 0, horizontal asymptote at y equals 0, and the graph looks something like that. So all of our graphs will be transformations of this little graph right here. Okay, so let's take a look at our graph right here. Speaking of, we can see the transformations. So again, just think to yourself right now, what are the transformations that you see here in this graph? Okay, well, the transformations are vertical stretch by 3, shift right 1, and up 2. Okay, our domain here, and again, we're just going to go through this like more thorough kind of description. Our domain, okay, well, what are the excluded x values? What x value here is going to cause a problem, right? We don't want x to be 1, positive 1. So our domain will be all the numbers besides 1. So it'll be from -infinity to 1, excluding the 1, starting back at the 1 again, and then going on to the right of 1 to infinity. Okay, what's our end behavior going to be here? Well, as x approaches infinity, f of x will approach what? And again, at this point, you can use your graphing calculators if you want to. You can also kind of evaluate this analytically by looking at your function here. Imagine with x approaching infinity, imagine plugging in bigger and bigger numbers for that x right there. You're then going to subtract 1 from that really big number, so you'll still have a really big number, but then you're going to have 1 over a really big number. When you take 1 and divide it by a ginormous number, it's going to get closer and closer and closer to 0. Then multiplying this value, which is essentially going to be 0, times 3, well, what's 0 times 3? It's going to be 0 as well. Then you add 2, and 0 plus 2 is going to be 2. So we're going to be approaching 2, okay? And specifically, we'll be approaching 2 from above, okay, from values greater than 2 in this case, all right? But again, don't worry too much about that plus there. If you don't want to put that in, that's fine. You can just leave it, blank. That's okay. Okay, then as x approaches -infinity, what will f of x approach? Well, again, you can analyze this by plugging in a -infinity, or you can also just use your graphing calculators table like we did yesterday. So by similar kind of reasoning, you'll end up with a positive 2 here as well. Again, if you plug a -infinity in for x, or a really big negative or really negative number, subtracting 1 will still make it really negative. 1 over a really negative number will be very close to 0, but on the negative side, times 3 will still be at a very close number that's very close to 0, still on the negative side. Adding 2 then will make it very close to 2, but from the negative side. So again, if you want to be technical here, we would put those little things in. Okay, so with that in mind, since we have this behavior that our function approaches 2, okay, that means we have a horizontal asymptote at y equals 2. Okay, so and then because of this domain restriction right here of 1, we know that we also have a vertical asymptote at x equals 1. X cannot be 1, so we're going to put this like boundary line here that shows that x cannot be 1. Okay, and then again, horizontal asymptote at y equals 2. Okay, just like that. Okay, now at this point you can make a table if you want to get some more points and stuff like that. So I always encourage people to just go like 1 x value to the right of the asymptote, 1 x value to the left of the asymptote. So I'm just going to plug it in 2 here. So make a little t-chart here. So I plug in 2. Let's see here. 2 minus 1 is 1. 1 over 1 is 1. 3 times 1 is 3. Plus 2 is 5. So 2, 1, 2, 3, 4, 5. Point right there. Okay. And then plug in 0 as well. 0 minus 1 is -1. 1 over -1 is -1. 3 times -1 is -3. Plus 2 is -1. So 0, -1. And there's our point right there. You can kind of see the symmetry, right? We went right 1 and then up 2. So we're also going to go left 1 and down 2. And there it gives you like 2 nice points. And then I only need you to get those 2 points, and we'll just kind of sketch the curve out. It's going to kind of just hug the asymptotes. Again, not ever crossing them, not ever touching them, but getting closer and closer and closer like so. And there's our graph. Okay, therefore the range, which I didn't get to talk about yesterday, well, since again you can see here we're not going to cross this horizontal asymptote in this case, so the range then is going to be negative infinity to 2 union 2 to infinity. Okay, so you'll notice here as well that our normal vertical asymptote for 1 over x is at 0, and the normal horizontal asymptote is also at 0. The shifts tell you where those horizontal and vertical asymptotes shift to be, right? So going right 1 and up 2, right, you can see that there's our new crisscross of the horizontal and vertical asymptotes. So we can use that, for example, down here in this one. Now, this one's a little bit trickier because you have the 2 in the denominator like that, okay, which is a different format than what we're used to. Up here we have that 3 in front, but we can fix that, right? This right here, okay, we can rewrite as 1 over 2 times 1 over x plus 3, like that, minus 1, right? Isn't that the same thing? Okay, that 1 here would multiply with this 1 to give us the 1 that we got from right there. And then this 2 would multiply with this x plus 3, okay, to give us what we had right here. Okay, so we can just, basically we're just going to factor out this 1/2 that's in front there to create the a value. Okay, now from this we can see that we're shifting left 3, down 1, okay, and it's stretched by 1/2. Okay, and so let's do it with the transformations instead. So normally our vertical asymptote would be right here. Oh boy, I'd have to like undo. Oh, nuts. Okay, so normally our vertical asymptote would be right here, but it's getting shifted left 3, so the vertical asymptote is going to be right here. Okay, likewise, we're also going to go shift down 1. Our horizontal asymptote would be right here, but it has to shift down 1, so now it's going to be right here. Okay, and then you can just pick an x value. Again, pick the x value, one x value to the right, one x value to the left there. So it's going to be -2 and -4. Okay, and just plug those into the function. Okay, when you do that, and if you're going to use your calculator, make sure you put parentheses around the numerator and parentheses around the denominator of your function too. Okay, and so if you plug in -2, you get -1/2. If you plug in -4, you get -1.5 or -3/2. So we'll just plot those points. So -2, -1/2, so right there, and then -4, -1.5, so right there. And again, just connect the dots and do not cross your asymptotes for these graphs. You only need 1 point. If you want to get more points, feel free, but there's the graph. Okay? Now, next. What if we want to graph this function? If you look at it, wait a minute, there's no transformations or stuff there. Oh, and I guess I should talk about these. So again, you can identify all this other information here now, you know, if you want to. It's the same kind of idea, right? You've got the graphs, you can answer all those things if you need to. All right. Now, what about this? This is not a clear kind of transformation of x, or 1 over x. So we need to rewrite it. How are we going to rewrite it? Long division. So we're going to do the long division here. I know, I heard your groans from across the internet. So rewrite long division. We're going to ask what times x will give us a 3x here. Okay, and so that's a 3. So 3 times x is 3x. 3 times the -1 is -3. Subtract that quantity, but instead of subtracting, I will add the opposites. Okay, so those cancel. -4 plus 3 is -1. There's a remainder, right? So how do I write the remainder? Plus -1 over x minus 1. Or -1 over x minus 1 plus 3, right? Pull that negative out front, and voila, there's your transformations. Right 1, up 3. So right 1 means we're going to have our vertical asymptote right here, and then up 3 means we're going to have our horizontal asymptote right here. Okay, and then again, pick some points. Okay, and your graph will look something like this when you pick some points, because that -1, that's what the reflection kind of makes it look like that. Okay, if you just pick, like, you know, the x value of 2 and plug it in, plug in the x value of 0, and you'll get points that, you know, result in a graph that looks like that. Okay, Last thing here, we also want to write the rational function from a graph. So we were going to look at this and let's interpret it. So again, we have our transformations here. We can kind of see we've shifted right 3. So that's going to result in x minus 3 for that right 3. And they're going to shift up 4 from our normal horizontal asymptote because it's at 4 now. And so plus 4, like that. The only thing left to do is to figure out what that a value is. Okay, but we have these points here. So we have the point 4, 6 or 2, 2 to help us figure that out. So pick one of them. I'm going to use 2, 2. So I'll plug 2 in for the y, 2 in for the x, okay? And then just simplify. So 2 minus 3 is -1, so we get -1 plus 4 there, okay? But it's a times -1, so don't add the -1 and the 4. Okay, we have to just solve for a. So we'll subtract 4 on both sides, right? You get -2 equals -a, and so a is 2. And so the final answer would be g of x equals 2, 1 over x minus 3 plus 4, like so. Okay, and there's our answer. All right. So yeah, I'll give you guys your assignment. Let me know if you guys have any further questions. All right, and we will get into some more complicated rational functions in our next lesson. Have a good day, guys. Bye.